Edupedia World Grade 10 Computer Science Video Lecture Series. I'm Upeka Vendibona, and from this episode we are going to start programming with C++. Here we are going to present the simplest C++ program, Hello World. The purpose of writing this program is to let you try your programming environment, and also we will give you a first feel of how you can get a computer to do something for you. So here we present the notion of a program, the idea of translating a program from human readable form to machine instructions using a compiler, and finally executing those machine instructions. Now to get a computer to do something, you have to tell it exactly what to do. Such a description of what to do is called a program, and programming is the activity of writing and testing such programs. In contrast, computers are really dumb. They have to have everything described precisely and in detail. To describe things precisely for a computer, we need a precisely defined language with a specific grammar and well-defined vocabulary for the kinds of action we want to perform, and English is far too loosely structured for that. Such a language is called a programming language, and C++ is a programming language designed for a wide selection of programming tasks. Now here is our first program, Hello World. Think of this text as a set of instructions that we give to the computer to execute, much as we give a recipe to a cook to follow. So this piece of code will output "Hello World" to your screen. Now before trying this out in a programming environment, let's discuss what each line of this program does. Take a look at the cout line. That's the line actually produces the output. It prints the characters "Hello World" followed by a new line. That means after writing the "Hello World", the cursor will be placed at the start of the next line. The cursor is a little blinking character or line showing where you can type the next character. In C++, string literals are delimited by double quotes. That is, "Hello World" is a string of characters. \n is a special character indicating a new line. The name cout refers to a standard output stream. Characters put into cout using the output operators lesser than 2 times will appear on the screen. Cout actually is an abbreviation of character output stream. You will find abbreviations rather common in programming. Naturally, the abbreviation can be a bit of a nuisance the first time you see it and have to remember it. But once you start using abbreviations repeatedly, they become second nature, and they are essential for keeping the program text short and manageable. At the end of that line, you will see 2 forward slashes with output "Hello World". That is a comment. In this program, you will see 2 comments. The first comment says this program outputs the message "Hello World" to the monitor, and the second comment is what we have talked right now. Anything written after the token slashes twice on a line is a comment. Comments are ignored by the compiler and written for the benefit of programmers who read the code. Here we use the comment to tell you what the beginning of that line actually did. Comments are written to describe what the program is intended to do, and in general to provide information useful for humans that can't be directly expressed in the code. The person most likely to benefit from the comments in your code is you. When you come back to the code next week or next year and have forgotten exactly why you wrote the code the way you did, so document your programs very well. We will have another episode to explain this matter very specifically. A program is written for 2 audiences. Naturally, we write code for computers to execute. However, we spend long hours reading and modifying the code. Thus, programmers are another audience for programs. So, writing code is also a form of human-to-human communication. In fact, it makes sense to consider the human readers of our code our primary audience. If they don't find the code reasonably easy to understand, the code is unlikely to ever become correct. So please don't forget, code is for reading. Do all you can make it readable. Anyway, the comments are for the benefits of human readers only. The computer doesn't look at the text in comments. And that's enough about comments. Now let's go for the first line. It's a hash include directive. It instructs the computer to make the standard C++ stream IO facilities available. Here we just use the standard output stream cout and its output operator to lesser than marks. Okay, now how does the computer know where to start executing program? It looks for a function called main and start executing the instructions it finds there. Here is the function main of our hello world program. Every C++ program must have a function called main to tell it where to start executing. Now I'll explain a little bit about what is a function. Function is basically a named sequence of instructions for the computer to execute in the order in which they are written. A function has four parts: a return type, the name, parameter list, and the function body. In here we have avoided having a return type because this function doesn't return anything, and the name of this function is main, and also we doesn't have a parameter list. If we have a parameter list, we will include that inside of the parentheses. And in the function body, we have a cout statement. Now that green colored statement in here using namespaces std, it's another topic about namespaces, but anyway I'll mention this. If we doesn't include this statement, we will not be able to run this program in this way. If we avoid this statement, you have to write the cout as std, two colons, and cout. For each time when you use the cout, you have to do that. So using the namespaces, you can avoid that much of long statements. Good. Now you know everything inside in this code. Now let's talk about compilation. C++ is a compiled language. That means to get a program to run, you must first translate it from a human readable form to something machine can understand. That translation is done by a program called a compiler. What you read and write is called source code or program text, and what the computer executes is called executable, or else we say object code or machine code. Typically, C++ source code files are given the suffix .cpp, for example, hello world.cpp or .h, and object code files are given the suffix .obj in Windows and .o in Unix. The compiler reads your source code and tries to make sense of what you wrote. It looks to see if your program is grammatically correct, if every word has defined meaning, and if there is anything obviously wrong that can be detected without trying to actually executing the program. You'll find that compilers are rather picky about syntaxes, leaving out any detail of our program such as hash include files, a semicolon, or a curly brace will cause errors. Similarly, the compiler has absolutely zero tolerance for spelling mistakes. We are going to look at that matter when you get familiar with the programming environment. Now let's talk about linking. A program usually consists of several separate parts often developed by different people. For example, the Hello World program consists parts of the C++ standard library. These separate parts, sometimes called translation units, must be compiled and the resulting object code files must be linked together to form an executable program. The program that links such parts together is called the linker. Now take a look at this illustration. Here we have a C++ source code, hello world.cpp, and using a C++ compiler, we can obtain the object code hello world.obj. In our source code, we have a hash include directive. It says to include a standard C++ library. The files in these libraries are also in the form of object codes. For our object code to be worked, these object codes should be connected. So this connection is built by the linker. And this linker will provide us an executable program as hello world.exe. I hope you got the idea what linker does. Now please note that the object code and the executables are not portable among systems. For example, when you compile for a Windows machine, you get object code for Windows that will not run on a Linux machine. So it's dependent on the platform. Another thing I want to mention about is libraries. A library is simply some code, usually written by others. We can access them using declarations found in hash include. A declaration is a program statement specifying how a piece of code can be used. And also, we cannot forget talking about errors. Errors found by the compiler are called compile time errors. Errors found by the linker are called link time errors. And errors not found until the program is run are called runtime errors or logic errors. Generally, compile time errors are easier to understand and fix than link time errors, and link time errors are often easier to find and fix than runtime errors and logic errors. We'll discuss errors and the ways of handling them in greater detail in another episode. And with that, we are going to wind up this episode. I hope you got the rough idea on how to program with C++. From the next episode, we will practically do what we have learned in here. So thank you for watching and stay tuned on with Edupedia World.